Hi students, welcome to this tutorial on analog and digital recording. We've already discussed in prior videos and also in class the basic analog signal path. In this video we're going to discuss the actual recording of that signal, either analog or digitally. First thing I thought we would do would be to review real quick the analog signal path. So, as you know from my prior drawings, here's a microphone tied to an XLR cable. It goes over here to a channel strip in our mixer. Okay, so this is our mixer. And you know from prior discussions that in each of these we have separate elements. We have a preamp, a microphone preamp. We have inserts that affect the entire signal. We have sends that allow us to send part of the signal to different locations. Then here we have the input and output section. Here we have the ability to pan our audio from side to side. And then here, lastly, is our volume fader. Once we've started this signal path, where does it wind up going? Well, in live applications, we're going to take the signal path here, and eventually we're going to get to some speakers. So that's a speaker, and that's a speaker. But before we actually get to the speaker, we have to gain up the signal. The important thing to remember here is that to actually move a woofer and a tweeter and a speaker requires a significant amount of energy and electricity. And our signal coming from here through the channel strip to our speakers is not significant enough to actually make the speakers move. So we have to amplify or gain up the signal in order to create enough power to move those speakers. We do that with an amplifier. Okay, so this box right here is an amplifier. It magnifies or amplifies the signal to such a strong degree that it can power the speakers and move those cones or woofers so that we can wind up hearing the sound. Okay, so that's the basic path then that we would use in, for example, a live situation. Maybe where we just want to use this signal path to support our sound reinforcement, or another term is a PA. Now, one of the things to talk about with these speakers is that there's really two kinds of speakers. There's a speaker that we can call active, and there's a speaker that we will call passive. An active speaker takes the actual speaker itself and puts the amplifier inside of the speaker. Okay, so an active speaker contains the amplifier itself. A passive speaker is kind of what I have notated here on our diagram. It is a speaker that is separate from the corresponding amplifier that powers it. Okay, so passive speakers do not contain an amplifier. You'll need an external amplifier to power them. Active speakers do contain an amplifier and don't need any other additional power sources other than the amplifier. So now the question might be, what is the difference between what I have diagrammed here that we could use for a live setup and a recording situation where we want to record the audio? Okay, the only difference will be that we have to, in some way, store the audio data. The way we do that, recording with analog, is to store the recording on a tape machine. In other tutorials, we already discussed multi-track recording, and we've discussed the basic audio signal path. So you know that music is going to be recorded on a variety of different tracks. On these older 2-inch tape machines, the common head stacks were 16, 24, and 32, the most common being 24 tracks. So we have 24 tracks available to record or to store our audio data onto. And after we've stored it and we want to play it back, again, we're going to come from our tape machine, and we are going to then come to an amplifier, and then come out here to our 2 speakers to reprocess the audio so we can hear it. So that's a standard 2-inch tape configuration, showing you the whole entire signal path from capturing the original sound with a microphone, converting it using a transducer to electrical energy, and then changing or altering our audio stream as we come through our mixer's channel strip. And we're gaining up that signal in our preamp. We're adding effects that will affect the whole signal with an insert. Sends, we may be sending a portion of the signal over to a different location for some other reason, maybe to add reverb to part of it. We assign our inputs and outputs, our pan knobs where we want the audio to appear, and then lastly, we have our fader here to control the output volume. One question that I may ask would be, what's the difference then between analog and digital recording? Well, let's start with analog. Analog recording has obviously been around the longest, so let's talk about some of its traits or characteristics. First of all, through the whole entire signal path that we've discussed, we are adding noise and we're adding distortion to the sound. We're changing or altering the sound. Okay? How do we do that? Well, when we convert the acoustic energy to an electrical signal using a transducer, a microphone, we are in some way coloring or changing the sound slightly. We're distorting the sound in one way or another. Same thing when we go through the basic channel strip in our mixer. We are changing or altering or coloring the sound. That's one of the things that a microphone preamp does, is it will color your sound. And then when we go to the analog 2-inch machine to record the music itself, we are again adding a variety of forms of noise or distortion. So when we talk about distortion, what is that? Well, one of the ways that I like to suggest that students think about distortion is in an image format. If we take a basic image and we import it into an application like Photoshop, we can add a variety of filters or in some way distort the image. What happens when we distort the image? Well, it changes or alters the image. So the concept of distortion is really a way that we are altering the audio. This can be a good or a bad thing, depending on what you're looking for and what the desired outcomes are of your recording. Adding distortion to a sound can be a positive thing. It can also be a negative thing, depending on what you want. With analog recording, the tape itself, you're going to get some distortion, some artifacts in the process of actually recording the electrical signal onto a piece of tape. Okay, so you're inherently going to add some distortion. Now, one of the things that this may give you is warmth to your recording. Now, you may go, well, wait a minute, how can distortion actually give me warmth? Isn't distortion a negative thing? Not necessarily. If you distort an audio signal, again, let's go back to that analogy of a Photoshop, an image in Photoshop. If you take and distort that image and make it less clear, it may actually make the picture look warmer, smoother, more inviting. If you think about some of the early films that were created that were analog films, and one of the techniques that they would use is that they would put a lens on top of the camera or in front of the camera that would distort the image. Oftentimes they would call it a soft filter. Many times what it was just a piece of glass with like Vaseline around the outside to soften or distort the image on the outside of each frame in the film. So by changing or distorting the image, it created a warmer look. Romantic scenes, they would use soft filters, or on a picture of a woman, they would maybe use a soft filter to distort the image and make it look warmer and more gentle and more inviting. The Wizard of Oz had some great examples of using distortion to soften or warm up the image. When they would take a shot of Glenda the Good Witch or a shot of Dorothy, they may use a soft filter to distort the image and make it look softer and more warm. Same is true of audio. If you add distortion, a slight amount of distortion to an audio signal, you can make it appear or sound warmer, okay? So distortion can be used to warm up the sound. One of the other things that you might find that might be maybe a positive or a negative with analog recording is the noise from the tape. If you remember back a number of years ago when cassette tapes were still popular, you remember that as you record to a cassette tape, if you didn't record the song loud enough onto the tape, you would actually hear a fair amount of tape hiss or noise. So tape hiss or tape noise is a common artifact found in analog recording. It was usually a high frequency hiss, kind of a kind of sound. Lower grade tapes, you'd hear more hiss. Lower grade tape machines, more hiss. But even on the 2-inch very expensive tape machines with expensive reels of tape, you would still get this tape hiss or tape noise. One of the things that they would often do to try to remove this was use a product manufactured by a company called Dolby. Dolby produced a product called SR, Dolby SR, that was a high-end noise reduction piece of hardware that you would need to have on each individual track. If you had a 24-track machine and you wanted to reduce the tape noise or tape hiss on individual tracks, you would have a Dolby SR module on each track. So this was a relatively expensive solution to the tape hiss problem, and oftentimes you could spend $15 to, I don't know, I think roughly $20,000 for a rack of Dolby SR that would de-noise or de-hiss your audio recordings. One of the other things I wanted to mention that may be a plus or minus, usually it's a plus, is something called tape compression. Okay, so what is tape compression? Tape compression is a process by which you send so much signal to the tape recorder that you are overdriving the track. And when you overdrive the track, the tape naturally compresses. Not physically, but the audio data that's going onto the tape is compressed onto the tape. And they found that early engineers found that they kind of liked that sound on occasion, especially for drums or other instruments that had very strong transients or attacks. So they would use this element of overdriving the tape to create tape compression.